Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, Editor-in-Chief at Automation World, and the question we'll be answering in this episode is, what IT technologies are having the most impact on operations? Now, the convergence of information technology and operations technology has become a well-worn topic over the past decade. And while many operations technology professionals remain focused on the core industrial technologies they've traditionally worked with, the business realities of having a connected enterprise have led IT professionals to learn more about operations technologies and likewise required operations professionals to learn more about and more frequently work with IT technologies. So basically, the days of having this black box of manufacturing operations that are walled off from corporate IT, aside from maybe one Ethernet connection delivering required data to the front office, have long passed. The connections are far more widespread now and have to be for manufacturers to run not just competitive but viable businesses. Now, Inductive Automation's Ignition platform first became well known in industry for its ability to easily develop open SCADA and HMI systems that are effective and reliable at a much lower cost than the closed SCADA and HMI technologies widely available in the market. But the open nature of the Ignition platform enables it to be used for much more than SCADA and HMI. Because it's designed to work with standard IT technologies such as SQL and Python, as well as operations technologies like OPC UA, users can connect data and applications across their business, from the plant floor to the front office and with supply chain partners. And that's why we're connecting with Kevin McClusky, Inductive Automation's Chief Technology Architect, to help our audience get a better grasp on the IT technologies they should be most aware of from an OT perspective, because this is the space Inductive Automation has always existed in. So thanks for joining me, Kevin.
Yeah, it's great to be here. Thanks for having us on.
So, let's start off with one of the big ones we've been covering for many years now, MQTT. This is the messaging technology that was originally designed for industry in 1999 for a project at Phillips 66, but then it gained wide acceptance in IT, even with high-profile consumer applications like Facebook Messenger and Instagram. So, from an OT perspective, what should our audience understand about MQTT and its use in industry?
That's a great question. There's a couple of things about MQTT that most folks know the acronym at this point, the message queuing telemetry transport. MQTT, so I'm a technologist, that's my background, and I get very passionate about these types of things. So I apologize if I get a bit deeper than maybe we're looking for right out of the gate. But to keep it relatively simple, MQTT, you could think of it as having two different layers. One would be simple MQTT communication, that if you see something out there that says we support MQTT, it's going to support simple MQTT communications. That's the equivalent of if you were going to call someone, I have a phone number, I'm able to actually pick up the phone and call. Then there's data formats on top of MQTT that allow systems to have some sort of a contract, a language between them. So if I pick up the phone, I'm going to be speaking English instead of French or German or Spanish, right? And so I know already when somebody's talking to me what language that they're speaking. So MQTT itself is the communication mechanism. It's that layer. And then on top of that, you have some data formats. So when you say, what should the audience understand about MQTT and how it's used in industry? I think the most important thing to understand is that MQTT is a great communication protocol for sending standard data, simplified data over between one system and another. But if you want to have a format of data that's going over that Then you need to have an agreed upon contract between the companies, between the different software packages that are being used. And the most common one right now is Sparkplug. And that's one that we have a lot of experience with and has a lot of great benefits. So for example, it guarantees that you're going to have data points. Those data points are going to have timestamps that are associated with them. They're going to have quality that's associated with them. If the originating system has engineering units, you're going to be able to see, oh, is this speed or is this PSI, right? It's going to have some sort of a measure in there, and you're going to have a guarantee of knowing when something's connected or disconnected if you're using that Sparkplug format. So to me, that's probably the most important thing to understand from the MQTT space. Of course, MQTT is built in a way that has security built into it, as modern network tech, capability and communications. It's one of those protocols, as you mentioned, that's really widespread. So it's really well supported.
And one of the things that first got my attention about MQTT was how it mitigated the whole PLC polling, data polling issue with that. Can you explain a little bit about that for our OT audience, about how that mitigates that issue, so that, especially with more applications needing data from the control systems, that the role that MQTT plays in that?
Sure. Yeah, there's a handful of controllers that support MQTT directly on the controllers. So, Opto22 as their Groove Epic. They're not paying me to say their name. Right? They're just folks that we know well, and they have MQTT Sparkplug built directly into their devices. What that ends up doing is just sending changes over the network and not having a polling and response kind of cycle between the device to see what has changed over time. Because it's just a send on change style protocol, it ends up being something that you can subscribe centrally. It publishes from the edge, and then you're getting a lot less data than you would if you were doing traditional polling over something like Modbus to a bunch of different field devices.
Okay. And you mentioned earlier, MQTT's secure communication capabilities. Can you explain a bit about what makes it secure?
Yeah, it has 3 different layers of security inside MQTT. And one of the nice things is that it takes advantage of certain pieces of security that are standard IT security. So built into it is the same security technology that's used by your banking website. So it has encryption that's going to be TLS encryption behind the scenes. It does support actually one step beyond your banking website, which is client-side certificates that are used for these as well. So that as a technology inside the security space when it comes to encryption and TLS, where you can have a pre-agreed upon contract between the different folks that have the basically guarantee that the communication that you have sent from one spot is coming from the place that you expect it to. And these security certificates can be required for this communication. That's an option inside MQTT. It also has username and password. And then depending on the MQTT brokers that you're using, the servers, they can have access control lists or ACLs, which end up allowing you to basically allow or disallow different communication that's coming from different areas, from different IP ranges, from different geographic areas, and you can have different sets of rules for read, write, accessing history, sending certain commands, depending on who the audience is and what the connected system is.
Thanks for explaining that, Kevin. Can you give us a few examples of, because I know Inductive Automation, works with, companies across the discrete and processing industries. Can you give a couple of examples of how you're seeing MQTT used most often in industry?
Yeah. The most often and the earliest adopters of MQTT were mainly doing it from the plant or from the location, from the site to a central location, which could be the cloud, it could be a central data center, it could be a corporate office. And basically bridging the gap between those two in a way that they could send everything over. Earlier, you mentioned the difference between polling and the way that MQTT does data. Because MQTT is a very lightweight protocol, you can have a number of different locations all sending information centrally. So one example I can think of is a company that has 70 locations, mostly around North America, who are sending basically millions of tags up into a central location. Ends up being somewhere around 70 to 100,000 changes per second, but not pulled for 3 million tags over that period. And all of those changes are going to a central location where folks are able to monitor, able to see in real time the data that's coming from each one of the different locations, and then do apples to apples comparisons across the locations from centralized dashboard, centralized reporting, send that information to AI and machine learning algorithms, and do whatever they want with the data once it gets to that central location. The other place that this is used from time to time, and we've seen this growing, is from the plant floor, from the edge devices, devices that PLCs that support Sparkplug, that support MQTT, up to a SCADA server, for example, where you have some semblance of visualization and reporting, and maybe some basic analytics that are sitting on site at a specific plant, at a specific location, site. Sometimes it's water, wastewater, that could be geographically separated, but it's still coming back to a local area or local site that's utilizing that data as well.
So it's almost more, and correct me if I'm wrong here, but it's almost more of the more common applications of it is more for inter-company site communications versus intra. Is that correct, or do you see an equal amount for somebody with one or two sites doing it? Is it mostly for the larger communications?
When we started 6 or 7 years ago with all of this, I believe that, so at that point, that's where it started, was that higher level intra-site type of communication. At this point, there's a mixture because it's become such a prevalent technology and so many companies have adopted it and support for it that we're seeing it both at the plant floor level and at the site-to-site and central communication level.
Now, containerization, that's another very common IT topic that we've been seeing a growing number of examples of for industrial technologies. Can you explain what containers are for an OT audience?
Sure. And for an OT audience, containers have a lot of complexity, but they're actually really simple in the concept. So if we go back, 20 years, and we think of a single server, and we say we want to take this server, but we want to make it so it's not a real physical server. We just want to take everything that's running here and move it over to another box that's sitting somewhere, whether that's the cloud, whether that's sitting inside a server room, but you can move it around. Those are virtual machines. We want to take this machine and make it virtual. And so I think everyone's heard of virtual machines and is familiar with virtual machines. The concept of the virtual machine basically evolved. So it came to the point that inside the virtual machine, it's running the operating system. What if we just had the applications in the virtual machine running, but we didn't have to copy all of the operating system, and we just wanted a really simple, small box, small area, small container to run this in that would run on another operating system or on another system. And so that's where the idea of containers came from. So a container is basically a contained application that is intended to be running really lightweight and can run on a platform that will run containers. And so the different containers that exist, there's a whole variety of technologies that are out there, but the concept of containers is really simple, and it's been accelerated as well in terms of adoption from the last couple of years here, where folks are moving away from VMs and toward containers for some of the changes that are happening inside the industry, changes in licensing models around virtual machines. And so containers have a lot of interest and a lot of staying power. They're also really lightweight, so you can potentially run them on things like edge devices instead of needing to have server farms to run virtual machines.
So what are containers most often used for in industrial applications, and what kind of benefits does it provide by using them?
Yeah, a combination. So a lot of containers do run on edge devices, like I just mentioned. So you can get edge devices that are small industrial PCs that have support for containers, and a growing number of PLCs or PACs actually have support for containers directly on those systems as well. So you can get the devices, if it says we support containers, you can take applications that are delivered in containers and run them on those systems. So Ignition, for example, which is our product at Inductive Automation, we have a release of that where instead of an installer that you install on an operating system, you can just grab the container. So we have a Docker container image that folks can take and basically spin up on any device that really supports containers. And so it's another way to run applications in a way that is self-contained from a security standpoint. There's strong security pieces between their separation between the container and other containers that are side by side, network routing rules. And as I mentioned, you can go deep with containers, but the idea is that that could be deployed on edge devices. You can also deploy them inside IT infrastructure. And so as IT organizations are moving away from virtual machines in a large way, moving to containers is a natural place to actually end up. And so we have quite a few IT organizations who are running containers that are sitting on servers, or containers that are running inside the cloud. And then IT gets particularly excited about containers because you can do things with containers that are a lot harder to do with virtual machines than containers. And in containers, they're relatively easy to do. So you can take containers, because they're relatively lightweight, you can move them around. You can put them on different servers. You can remap things inside the containers. You can manage them in a really lightweight way. And so a number of technologies have spun up around managing these servers, these containers that are sitting in different places. The container management is called orchestration, where you might spin up several different containers in different ways, put them in different places. And these orchestration systems, think of it as an orchestra conductor that say, you go here, we're going to set up the network routing rules between here in this way. Those orchestration engines, one of the most popular ones, and a name that's probably going to make sense, or at least that a number of folks have heard of, is Kubernetes. And so Kubernetes is I think, hands down, the most popular orchestration engine right now inside the IT space. And it's starting to find its way into the OT space as well. And so some of the benefits on the IT side, this is a benefits question, right, is that you can get away from the hardware in a real significant way. You can move things around. If a piece of hardware dies, you can automatically spin something up somewhere else. You can have the security patch cycle somewhat separated from the applications that are running on there, the different containers that are running in different places. It becomes something that's a lot easier to manage the security footprint on. And then when it comes to trying to adhere to something like the Purdue model, or just network security in general between different layers, it's something where you can easily and quickly move things around to different places inside your network, where it's still running exactly the same regardless of where it is, but you have the security layers in place there. And so a whole vast range of benefits that IT organizations are seeing from containers that also flow down to OT in a big way as well, in terms of, instead of managing virtual machines, managing containers can be a lot nicer. And as I mentioned, edge devices are able to run containers, or a number of them are, so it actually opens up the possibility of running more significant applications at the edge of the network versus you might have needed a virtual machine before, which requires additional hardware.
So DevOps is another topic like containerization that's, been well known in IT circles for years and is, gaining growing interest in the operations space. So what is DevOps?
DevOps is development operations, and that doesn't answer the question at all, does it? So basically DevOps is, you could divorce yourself from the actual word, and if we break it down just from what its constituent parts are. So development and then operations. When you're developing a product or developing anything that is going to be used on your plant floor, on the shop floor, out in the field, or you're developing software. Either way, you're going to go through a development cycle. And that development cycle, you're going to write some software, create an application, create a SCADA application, do, industrial integration pieces of things that you're going to be doing configuration. And then you're going to finish your development cycle, and then it needs to move. And so you've got to have some operations to move things around in a way that they're going to go into production. So software development works this way. Things that are deployed applications, if they're using a DevOps style inside the industrial space, works the same way as well, where you're going to go from development and then you're going to deploy something. And so the most typical way to think of DevOps would be develop something, and then what are my operations to get it into production, to get it packaged up in a way that it's going to be able to run well. Now, the traditional SCADA approach of 20 years ago is we're going to open up a designer, we're going to make some changes, we're going to hit the save button, publish it to production, and we're going to be done with it. So we're immediately making changes on our production system. We're not testing it, we're not going through, and if it breaks, then we'll fix it right away. We've got really smart people to fix it, and we're just going to do that, and then we're going to update it on that side. So our processes that we've had in the OT space for a long time are very different from IT, where they're more careful. They're going through to developing things, going through a test cycle, and from that test cycle, getting folks to come in. Sometimes they have different actual job roles, like QA roles, and they'll come in and they'll test whatever it happens to be. And then they will go through to a deployment setup where it'll end up inside some executable or program that's deployed widely around an organization. So applying DevOps to the OT space, it looks pretty similar, where you have a development system, you might have a test QA system, and then you have a production system or 100 production systems that are out there, where you're making changes not on production, but you're making changes on a development system that's alongside from it. And if you screw something up on the development side, it's not going to take down production. You're going to have that self-contained. You're going to be able to test it, make sure things are right before you go through an intelligent way of sending it out. Now, of course, there's a whole variety of tools that are around DevOps that software has used for a long time and now are available to be used on the OT space as well. Git is one of the most popular ones, GIT, but there's a whole variety, a whole set of stacks that are inside this space that could be used on both sides.
And one of the things that your explanation helped clear up for me, and so I just want to clarify that, is DevOps is not just related to creating apps to, if you wanted to check temperature and vibration on a troublesome machine and create an app for that, but this is something that can be used plant-wide or corporate-wide, such as SCADA or other types of operation systems. Is that correct?
Yeah, absolutely. And we have, I'd say our most, it's not most of our customers, but our most advanced customers are all using DevOps in some way on the SCADA side, on the industrial data visualization, the enterprise visualization side, on the, sometimes on the HMI applications as well. But it's super common when it comes to the bigger picture visualization platforms.
And so one thing that, and I think you may have answered it for me, one of my questions for you about DevOps was how it's being used in an industry and what its benefits are. And you've kind of answered that around visualization and SCADA. Anything else that you're seeing a lot with DevOps?
Yeah. In terms of the benefits, there's a couple of other things that are interesting there. So anytime that you're using DevOps, you do have changes logged. So it's a controlled change process. You're able to see things that have changed over time. You have snapshots, you have change control, you have version control tracking that's built into that. You also often will see benefits to system stability. There's an abstraction layer. And so if you're using containers, for example, you can connect a DevOps pipeline into container deployment. So it can send out at the very end of of the development cycle. You press a button, send it to test, press a button, send it to production, and have that push out automatically containers to different areas in the organization. It abstracts from the operating systems and the hardware, and it allows you to have something specific to test against as well. And then also roll back if something has problems. So you roll something out. Some engineers made a change in an application. You didn't catch a problem inside test or QA, and then that gets sent to production. You can very quickly say, I want to pull that one back, and then just deploy the previous version of it. That's very easy to do once you have one of these DevOps pipelines set up and ready to go. We do have some folks who are connecting to unit testing as well, which is also another IT technology. But just think of it as testing the application in a way that your engineer has written a script to test it, or somebody has gone through and clicked some buttons and said, record this, make sure that every time that I click these buttons, it does the same thing. And then they set that up inside a testing environment, like a Selenium, for example, is one of the common technologies to test web applications, which are, our Ignition perspective is a web application, basically, the clients are. And so folks will set things up to do automated tests for that. So you don't have to have somebody clicking on everything. You can have the system clicking on everything for you and verifying it before it even gets to the point that somebody's looking at it. So you can catch things very early on.
So one last topic that I wanted to touch on, because we've covered a bunch of fairly complex topics for a lot of industry here. But there is one last thing I wanted to touch on, and that's application management. With the growing use of apps, I know I mentioned, a lot of the self-created apps that manufacturers are doing for temperature, vibration, preventive maintenance types applications. There's a ton of others that are available as well, for specific functions, for maintenance to remote monitoring, workflow, et cetera. And that's all in addition to the traditional OT software applications that are available, SCADA, HMI, inventory management, and quality control. So from that, it's easy for both IT and operations to become overwhelmed with the management of all these apps that are designed to make work easier for operators. So I know in response to this, I know that IT has been focusing on this concept of central application management and deployment. And can you explain what that is and how it would work on the OT side as well?
Sure. Yeah. Easiest way to think of it is to think of Microsoft Office that IT is managing. So that's the traditional example that anytime you're in an organization, up until recently, at least, almost every system had Microsoft Office installed. And so Microsoft Office would be managed by the IT folks, deployed by the IT folks, patched by the IT folks. So that application is managed centrally. What you're talking about with inroads that are happening from an application management standpoint into OT applications is that the applications that IT managed used to be limited down to the ones that were deployed like Microsoft Office to all the different client systems, to all the different desktops that you might have and laptops across an organization. It didn't really touch the OT space. At this point, we're seeing a lot more folks doing it with applications that are going to the OT space. So sometimes those applications are created by the IT department. Sometimes those applications are created by OT, but then IT helps to manage those applications from a standpoint of making sure that they're running well, monitoring the applications, being the first level of tech support if something's going wrong for an organization, and having some sort of centralized standardization across that. And so in the SCADA space, for example, we have a number of folks who we're working with who have created standardized SCADA applications that are across the entire organization. Let's say we've got a weigh scale down here that every single one of our locations, we are using that to measure the quantity of product that's going across a certain area. And we want to compare apples to apples for all of our different locations. But we don't want folks to, at each one of our plants, to write their own application inside Ignition. We just want one application. And so they've written a single application that goes everywhere. It's managed centrally. It's used by every single one of the plants, but the actual application is managed from the central IT department. If there are any changes, improvements made along the way, those are made by the IT department as well. And then they're monitoring the database, monitoring the connections, monitoring the CPU utilization on these systems to make sure that things are going well there. We also have, I've seen a hybrid approach, and this might be a little bit more common, where IT is managing Ignition and they are monitoring to make sure still the database is working well, the CPU utilization isn't too high, the logs don't have errors in them, the communication to PLCs is in good working order, the network communication hasn't gone down between different key parts. But then you have the OT engineers who are actually creating the applications inside Ignition and managing those applications, managing them from a development standpoint. But IT is still that first line of defense when it comes to managing. It's in their purview. So they're the ones actually managing the application. The OT folks are supporting it from a development standpoint, from a fix standpoint, if there's anything to fix, improvements, new features, things like that.
Well, thank you again for joining me for this podcast, Kevin. And thanks, of course, to all our listeners. And please keep watching this space for more installments of Automation World. Get your questions answered. And remember, you can find us online at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.